You are looking at a creature called the vampire squid. That name is wrong. It is not a squid. It is not an octopus. It is the sole survivor of an evolutionary branch that split off 300 million years ago, long before squids and octopuses became two different things. Science classifies it into a completely separate order, Vampiromorphida, which it does not share with any other living creature on this planet. This is the vampire squid. And this is what it actually is. You are currently sitting about 3 miles, which is about 4.8 kilometers, above a specific body of water. That body of water starts at a depth of 600 feet, or about 183 meters, and extends down to 3,000 feet, which is about 914 meters. Its scientific name is the oxygen minimum zone, the area with the lowest oxygen content in the entire ocean. It is not completely devoid of oxygen, but it is so low that most creatures entering it would suffocate before reaching the bottom of the zone. At a depth of 3,000 feet, or about 914 meters, inside this zone, the oxygen level is only 3 to 5% compared to the surface. The temperature is maintained at 35 to 43 degrees Fahrenheit, which is about 2 to 6 degrees Celsius. The light is absolute zero. No large predators can survive here long enough to pose a threat. Below 3,000 feet, which is about 914 meters, inside the oxygen minimum zone, this creature has lived completely alone for 300 million years. Here is what most people believe about the vampire squid. They think it is a type of squid. They believe it hunts live prey in the dark. They assume the name vampire comes from its aggressive nature. The data does not support any of this. In 1903, scientist Carl Chun described this creature for the first time. He saw the webbing between its tentacles, its dark red color, its red eyes in the laboratory light, and he called it a squid. The name stuck. The classification did not. DNA analysis confirmed that it does not belong to the squids, and it does not belong to the octopuses. It is a third branch that split off before both of them, leaving no other descendants besides itself. Regarding its predatory behavior, the vampire squid does not hunt. It eats marine snow, which is organic matter falling from the surface in tiny particles, such as animal waste, dead algae, and the debris of things that died in the upper layers. This is the only known cephalopod that does not hunt live prey. The data does not support classifying it as a predator, and the name vampire does not come from attacking behavior. It comes from the black webbing spreading between its tentacles, which looks like a cloak when it contracts. When threatened, the vampire squid does not attack. It turns its body inside out, wraps itself in that webbing, and hides within itself. The vampire squid is about 12 inches, or about 30 centimeters, long on average. The diameter of its eye is 1 inch, which is about 2.5 centimeters. That ratio of eye to body size is the largest recorded in any animal on this planet. At a depth of 3,000 feet, or about 914 meters, the only light source is bioluminescence from other creatures, which is extremely weak and highly intermittent. Those eyes were not built to see far. They were built to collect every single photon in near absolute darkness. Its eye color changes depending on the conditions, turning blue in dim light and red when there is no light at all. This has been documented. The entire surface of the vampire squid's body is covered in photophores, which are light-producing organs. It can control each photophore independently, creating complex light patterns all over its body. At the tips of its tentacles, there are 2 larger photophores. When attacked, it lights up those 2 spots, while completely turning off the rest, creating a fake pair of eyes at its tail end to distract the attacker from its real head. It can also spray a bioluminescent cloud instead of black ink, which is non-toxic and causes no pain. It is just light in the dark, enough to cause disorientation for a few seconds. What has been recorded is this: a creature that has turned light into a tool of deception, not a weapon of attack. The vampire squid consumes less oxygen than any cephalopod ever studied. Its metabolic rate is so low that it can survive in the oxygen minimum zone, where most creatures would suffocate. Its gelatinous body has a density close to that of seawater, meaning it expends no energy to maintain its position in the water column. It does not need high-energy prey, because it has evolved to need almost nothing. Most cephalopods live for 1 to 2 years, reproduce once, and then die. The vampire squid does not follow that pattern. It can reproduce multiple times throughout its life, alternating between reproductive and recovery phases. This mechanism has not been observed in any other recorded cephalopod species. This reproductive pattern does not match any existing files. Here is what those 4 traits combined actually show. The vampire squid is not a deep-sea adapted creature in the traditional sense. It is not something that evolved to conquer a harsh environment. It is something that found a perfect environment and simply stopped changing. All of its traits are not new adaptations. They are the preservation of what worked 300 million years ago. The oxygen minimum zone does not trap the vampire squid. It preserves it. Because the OMZ is too harsh for most creatures to survive, no large predators can enter it. There is no competition. There is no selective pressure forcing it to change. The result is a body design from the Triassic period that has been kept completely intact to this day. Fossils of its ancestors look almost identical to the living creature today. This is so rare that science has a specific name for it, a living fossil. Squids evolve toward speed and attack. Octopuses evolve toward intelligence and flexibility. The vampire squid represents a third path, which is simplification, withdrawal, minimal energy, and hiding in an environment that no one else can endure. That path did not produce any other species. Vampiromorphida has only one single species left. This is the only living proof that this third path ever existed. The vampire squid eats marine snow and excretes dense fecal pellets that sink faster than normal marine snow. They are distributed throughout the oxygen minimum zone in all tropical and subtropical oceans. The global population size has not been determined. Their role in transporting carbon from the surface layers down to the deep ocean floor, which is part of the global carbon cycle, has not been fully quantified. The consequences of this are still being measured. There is no reliable method to determine the age of a vampire squid in its natural habitat. Specimens kept in captivity die quickly, so laboratory data cannot be applied to their behavior in the wild. Lifespan estimates range from a few years to decades. No numbers have been confirmed. How long the vampire squid has lived in the oxygen minimum zone is currently unrecorded. Its bioluminescence patterns are more complex than necessary for mere defensive purposes. Some researchers have recorded structured, repeating light patterns that could be signals between individuals. There are not enough observations in the natural environment to either confirm or refute this. Whether these light patterns constitute a communication system remains an unanswered question. The oxygen minimum zone is currently expanding. The warming of the ocean reduces the amount of dissolved oxygen. OMZs globally have been recorded as wider and deeper than they were 50 years ago. That means the vampire squid's habitat is changing in a direction and at a speed that has never happened in the 300 million years of this evolutionary line's existence. The impact of that expansion on the sole surviving member of a 300 million-year-old evolutionary branch remains an open file.